Good morning, class. Welcome to the online classes for physics of class 10. In the previous classes, we were learning about the chapter 10, that is light. Here we have seen that what the light is and what are the properties of light and the phenomena of light, that is reflection and refraction. And we have seen that whenever there is light bouncing back of light rays from the medium is said to be reflection, and whenever the light rays fall from one medium to the other medium, then these passage is said to be the refraction, right? And we have calculated the angle of incidence and refraction, that we have to take an imaginary lines perpendicular to the surface, that is the normal. Okay, and we have seen the type of the mirrors also. So in the mirror we have seen firstly that is a plane mirror, through which we have seen the example of the reflection. This mirror, it is a plane which is shown with the help of a straight line, and one is the reflecting surface and the other side is the non-reflecting surface. So the non-reflecting surface is shown with the help of the small oblique lines. And after that we have seen the spherical mirrors. So we can say that the spherical mirror is that mirror in which the reflecting surface is just the part of the hollow sphere. So we can say that the spherical mirrors are the part of the hollow sphere of the glass. Okay, and this hollow sphere can be of the two types, right? Because on cutting this glass we can take the two parts of the hollow sphere. One may be the bent-in surface and the other one is the bulged out surface. On the basis of that we had two mirrors, that is the concave and the convex mirror, right? Concave and convex mirror. So the mirror can be cut in the form of curve. If this is the oblique line that is showing the non-reflecting surface, and the inner part, that is the bent-in surface, is said to be the concave mirror. That is the reflecting part. When the bent-in surface is the reflecting part, then it is said to be the concave mirror. And if it is the inner bent-in surface is a non-reflecting and the bulged out surface is the reflecting part, then it is said to be the convex mirror. So it is convex mirror and this is the concave mirror. Okay, so here are two mirrors, and we have seen the parameters also, that how we just select the parameters of the mirror. We know that this is a part of a spherical, is a part of a hollow sphere. So we can say that this mirror is a part of a hollow sphere. So we can imagine that as the part of the sphere. So we can say that sphere has a center. So here for the mirror there is a center which is said to be center of the curvature, and it is shown with the help of the letter denoted by the letter C, and the distance between the center of the curvature and the part of the sphere is said to be the radius, similar to that of the normal sphere. And this part, which is the reflecting part or the reflecting surface of the mirror, is said to be the aperture or the height of that mirror. And if the light ray falls on the surface and reflect back, then the point through which it reflects back is said to be the focus. So we can say that whenever the light ray falls on the surface and get reflected back, then the point where these reflecting rays from the different beam of light meets at a point, and this point is said to be the focus. So this is the focus, and the distance between the focus and the point of the mirror is said to be the pole. So distance between the pole and the focus of the mirror is said to be the small length, that is focal length. It is focal length. And focal length, pole, center of curvature, radius, aperture, and height of the mirror, that is the aperture of the mirror, that is the reflecting surface through which the light can be reflected. This all are the parameters, right? What we have seen, pole, that is seen by the P, and the light ray, which is imagined to be the imaginary axis which passes through the center of the curvature and passes through the pole, is said to be the principal axis, that is XY is the axis and it is said to be the principal axis. And after that P is the pole, F is the focus, and small f was the distance between this P and F, is said to be the focal length. C is the center of curvature and R is the radius of curvature. So this were the part which we have seen in the spherical mirror, right? So we can say that concave mirror, if we see the figure, here are the parallel light rays when it falls on the concave mirror. See, if we take the parallel light rays, these parallel light rays passes through the center of curvature, right? If we take the pole, then it should pass through the center of curvature, and the point through the mirror is said to be the P, right? So these reflecting rays have to get reflected back, right? These light rays have to reflect it back, so they are meeting at a point. This point is said to be focus. So the point at which the reflecting rays from the parallel light rays beam are said to be the focus, and distance between these focus and pole is said to be the focal length. Okay, so this is what the relationship between the radius of the curvature and the focal length is. We know that focus point is the point where all the reflecting light rays meet. So we can say that for the concave mirror, it was behind the mirror, beside the mirror, that is in front of the mirror, that is the bent in surface, the focus is present. But for the convex mirror, we do know that this mirror, the parallel light rays moves, but they reflect back in the different directions. So how can they meet? So just we have to extend it at a point so where they can meet. Okay, so this meeting point is behind the mirror, so we can say that for the convex mirror, this focus is behind the mirror. So these light rays parallel to the surface of the mirror meets at the point behind the mirror for the convex mirror. So the distance between these pole and the focus is said to be the focal length small f. So what is the relationship between the radius and the focal length? We can say that behind the center of curvature, focus present, and these focus, the distance between the focus and the pole is said to be the focal length. So focal length will be half of the radius of the curvature. Okay, or we can say that radius is equals to twice of focal length. Right? So this is the relationship between the radius and the focal length of the mirror. So see here a sample problem, that if some question comes to you that the radius of the curvature is given as 20 centimeter, then what is the focal length? We know that focal length is just the half of the radius of curvature. So f is given and r is given as 20, it's upon 2. So focal length is 10 centimeter. Okay, so this is the relationship between the focal length and the radius of the curvature. Nextly, we will see what are the rules for obtaining the images formed by the concave mirror. So here some are the rules. These are the 4 rules in which you have to remember that how the light rays reflect back and what are the rules to get the image by the concave mirror. We know that in the concave mirror, the bent in surface is the reflected. So the light ray will reflect in the bent in surface and the light rays will reflect back towards the in front of the center. So the focus will be present in front of the center itself. So see the rules. By saying the first rule, you can say that whenever the light ray falling on the surface is parallel to the principal axis. Here you can see the principal axis given by xy. This is the principal axis xy, and these parallel light rays is moving and falling on the surface of the concave mirror. Then it reflects, right? It reflects, but we know that the incident light ray and the reflected light ray should have the same angle. So if we draw this imaginary line, we can say that the angle of incidence is equals to the angle of reflection, right? So this light ray passes through the focus point. Whenever the light ray falling parallel to the principal axis, then the reflecting ray will pass through the focus, that is point F. It passes through the point F. Right? So this is the first rule, that whenever a light ray which is parallel to the principal axis falls on the concave mirror, then the reflected ray passes through the focus, or we can say that the light ray passes through the focus after the reflection from the mirror. Now the second rule, whenever the light ray passes through the center of curvature, this center of curvature is imagined as the center of the sphere. So when the light rays passes through the center of curvature, then this light ray get back reflected to the same direction. So we can say that the reflected ray reflect back along the same path through which the incident light ray came. So this is the rule of the second light ray, that whenever the light ray passes through the center of the curvature, then the light ray reflected back from the mirror will also move through the center of curvature. Okay, now the next law is just the inverse of the first rule. In the first rule, we have studied that whenever the light ray is parallel to the principal axis, it always moves through the focus, and similarly on the inverse of it, whenever the light ray passes through the focus point, so object is kept at some point, and whenever the light ray parallel to that object passes through the focus point, so if that passes to the focus point, it will reflect back, but this reflected ray will be parallel to that of the principal axis. So both are same, but they are just reciprocal to each other, that whenever the light ray passes parallel to the focus, parallel to the principal axis, then the light ray will pass through the focus point, and if the light ray passes through the focus point, then the reflected light ray will be parallel to the principal axis. Okay, so last law that whenever the light ray will fall on the pole of the concave mirror, when this incident ray is incident on the pole, then it will reflect back with the same angle of incidence and with the same angle of reflection. We know that whenever the incident light ray falls on the surface, then it will reflect back with the same angle of incidence and reflection. But if it falls on the pole, so we can say that it will make the same angle with the principal axis, because here see, this is similar to that of the figure of the reflection. See, whenever the light ray falls and it reflect back, we know that we have to imagine a straight line that is perpendicular to the surface, and it is here this normal is similar to that of the principal axis of the mirror. So we can say that the principal axis is making an angle with the reflected ray. So whenever the light ray is incident at the pole of the concave mirror, then the reflected back making the same angle with the principal axis. So the angle of incidence and the angle of reflection will be of the same with the normal as the principal axis. So these are the rules for the formation, or we can say that the rules of the light rays passing through the concave mirror. So now to see the image formation, we have to see some rules that how the image is formed while keeping some points. So the formation of different types of images, we have to keep the object at different times, or we have to assume that if the objects are kept at these points, then the image will form at a particular point. And how this image will form. So here are some points we can see. There are the 6 points through which we can tell that if the object is kept at some point where the image will form due to the concave mirror. So if we take this concave mirror, just imagine that this is the spherical mirror, then this is the center of the sphere, and the point F will show where the light rays will meet, and the distance between these pole and the focus will be shown by the small f, that is the focal length. And if the light rays passes or the object is kept at the infinity, then it is some distance at infinite point. So we cannot just have to imagine, we cannot find out that point. So here are some points where we are going to place the objects, that is between the pole and the focus. If you put the object between the pole and the focus, okay, so this arrow shows that it is kept at the pole and the focus. And the second point, if this object is kept at the focus itself, if it is kept at the focus, now we will be seeing that if the object is present here, then where the images are going to be obtained. And after that, beyond the center of curvature, that is beyond the center of curvature. Okay, after that we are going to see if the object is kept at the distance, infinite distance, we can say that it is kept, or the distance cannot be shown with the help of the figure. It is kept at some distance which cannot be found. Okay, so we are going to see where this image is formed in the objects are kept at some particular points. Now here you can see the image formed of the concave mirror when the object is placed between the pole and the focus. You just have to remember the points of the light rays, and also have to remember the points where the image is formed when the object is kept at some point. So let us consider that the object is kept at the point between the pole and the focus. So if this object is kept, and this is the source of the light, this eye is showing the source of light. So the parallel beam of the light ray will be falling from our eyes, so that this light ray will be incident on this object, and this object will reflect back. But see here that from the focus, can it reflect back? It will reflect back, but we cannot find the point where they meet. So to find the point where they meet, because whenever the light rays meet at some point, this reflected light rays, there itself the image is formed. So to show the image, we just have to extend the point of this reflected light ray. So on extending the point, we have find some point where this A dash and B dash, this is the image. So we can see this image formation, and we can tell that whenever the object is kept at the point between the focus and the pole, then the image is formed just behind the mirror, and the image is just magnified. So we can say that is enlarged, or the object is of small height, and the image is just magnified or the enlarged than the object. So the image height is more, and since it is formed at the behind the mirror by the extension of this reflected light ray, so the image formation will be of like a virtual image. It is not a real image. So what is the nature of the image? It is virtual, and we know that whenever the virtual image is formed, they are erect, not inverted, so they are of the erect. So we can say that the image formation by this concave mirror when the object is kept between the focus and the pole, it is virtual and erect, and it is found behind the mirror. And we know that the object image is enlarged than the object, so it is magnified. Okay, so we can say that whenever the object is kept at between the focus and the pole, then the object is magnified. Here are some examples that whenever the object is kept at between the focus and the pole, then the object is formed with an image which is magnified. So the first example, that is concave mirror, which is already used for the magnifying the object, because the magnification glass you have seen that whenever we see an object we get the image enlarged. So this is the type of the concave mirror where the object is kept between the focus and the pole. And secondly, the concave mirror used for the makeup. Here also the object is magnified, then only we can see this, how we have to put some makeup or some lining. When we use it, then we have to see the enlarged object, right? Image should be enlarged one. After the dentist mirror, it is the concave mirror which is placed at the handle. It is placed at the long handle. It is placed inside the teeth so that he can see the magnified image of the teeth. Similarly, there are various other points where we have to keep the object. Secondly, when the object is placed at the focus of the concave mirror, here whenever the object is placed at the focus, then the image will be formed at some infinity point. But here it is formed in front of the mirror, so the image formation will be real and inverted, because real image is always inverted. So if it is formed behind the mirror, then it will be virtual, and if it is formed in front of the mirror, then it is real image, and the real image will be the inverted image. Okay, and since it is formed at the infinity, so we cannot find the distance, but we can say that the image will be highly magnified, so the image will be of a height. So we can say that the height of the image will be more than that of the height of the object. Okay, so similarly we will be saying the third point, that whenever the object is placed between the focus and the center of curvature. So if the point is kept at between the object's point is at between the center of the curvature and the focus, and the image is formed at some point beside the center of the curvature, that is behind the mirror but beside the center of the curvature. So the image formed is highly magnified, that is more than the height of the object. Okay, so there are some rules at how this image formation is done. So remember these points and by heart, that how the image is formed and what is the nature of the image. So first point, that whenever the object is placed between the focus and the pole, the object is fine, that the image is formed behind the mirror. So if the object is fine, the image behind the mirror, then we can say that the image is virtual, and the virtual image is always the erect image. Similarly, when the object is placed at focus, then the image is formed at infinity. Similarly, when the object is placed at infinity, then the image will be formed at focus. Similarly, they will be both together reciprocal to each other. So if the object is kept at focus, then the image is at infinity, and if the object is kept at infinity, then the image will be formed at focus. So the object in nature is real and inverted because it is formed behind the mirror. So in front of the mirror, the object is real, and the real image is always in the inverted. And when the object is kept at C, then the image will be also formed at the C, but it's inverted, so it is a real image. Similarly, when it is kept beyond C, then between F and C, and if the object is kept between F and C, then the image will be formed beyond C. So we can say that some points are reciprocal to each other, so you just can remember easily. Right? Now we'll see what the uses of concave mirror. We know that this concave mirror converges the light rays and also gives the image real and the inverted many times, and give a one virtual and the erect image that is highly magnified. So on keeping the object at focus, we can get the highly magnified object, but it is at infinity. So keeping the object at between the focus and the pole, then the object gets infinite not, but the magnification is good and the image formation is virtual and the erect. So where are the points where we use this concave mirror? Concave mirrors are used as the shaving mirrors, as a large image of the face, so that we can see the large images of face. And similarly, it is used by dentists to see the large images of the teeth. And it is used as a reflectors in the torches, because so that the light rays can reflect good. Okay, so reflectors can direct heat rays into the whole room. Next, concave mirrors are used as the doctor's head mirror. There also they focus the point by seeing the eyes, ears, teeth, many more things, throat, so that they can get the highly magnified image. Similarly, concave dishes are used in the TV dish antennas to receive TV signals from the communication. right? Because at the earlier points, not now, but in the ancient times we used to, not ancient times but yeah, in the modern periods itself, but in the middle ages, that is the 19th centuries, we used to make a TV which is a box like structure. You may have seen the TVs, that the structure of the screen of the TV used to be concave mirror, like the bulged out surface is there and the bulged in surface used to be reflecting. So the image formation is done in the bulged in surface, but the bulged out surface can be seen outside from the TV which we used to see. And nowadays the TVs are used with the flat surfaces, so here the surfaces are flat. Similarly, the large concave mirrors are used in the field of the solar energy to focus sun rays. They are used in the solar furnaces, and the reflector is kept so that the furnace get very hot and the reflected rays can get into the reflecting surface. So these are the points where the concave mirrors are used. Now for the spherical mirror, sign conventions are same, so we can say that it can be used for both, that is convex mirror and the concave mirror. So here are the points which we have to remember during the sign for the spherical mirror. So if the object is kept at the left side, we know that this is the left side of the x-axis, so it should be negative. So object placed on the left side of the mirror is taken as negative, and the object placed at the right side, so we can say it as a negative, taken as the positive. So the object kept in the left side of the mirror is taken at the distance of negative, and if the object is kept at the right side, and it is taken as a positive. Okay, and many more reasons are also there, that if it is taken at the height of the object, then if it is kept at the top, then it is at the positive y-axis, so the value will be positive, and if it is kept at the bottom part, then it is similar to that of the negative y-axis, so it will be negative. So the distance is taken against the incident light will be negative, and if it is taken with the incident light direction, then it is positive. So these are the sign conventions which we have to use in the numericals also. Okay, so here we are going to see the mirror formula. So this mirror formula just gives the relationship between the object distance, image distance and the focal length. Here whenever the object is kept from the point pole, then the distance between these pole and the object is said to be the pole object distance, and this object distance is denoted by the letter U. And similarly, the image formed, then the distance between the image and the pole is said to be the image distance, and it is shown with the letter V. And the focal length F, that is the distance between the pole and the focus. So this mirror formula just relate this image distance, object distance and the focal length. So what the mirror formula tells us, that is 1 by V plus 1 by U is equals to 1 by F. Okay, so we will be using these formulas, and by the mirror formula we will be considering the sign conventions also to find the V, U and F. So now the magnification or the linear magnification produced by the mirror. Now only we said what this magnification is, that what the image formed is from the object. What is the height of that image formed than the object, or the ratio of this both image and the object height. So we can say that if there is a difference in the size of the object and the image, then we can say that the image is magnified, right? Image of the object is magnified, so the height should be more. So we can say that this magnification can be defined as the ratio of the height of the image as well as the height of object. So h2 upon h1, where the h2 is the height of image and h1 is the height of object. So height, if it is erect, that the virtual image will be positive, because the object is always, the image form will be erect, so it is on the top of the y-axis, so it will be taken as positive, and if it is taken the bottom part, then it is taken as the negative, so the real images will be negative. So we can use the sign conventions for this also. And similarly, this magnification can also seen with the help of the ratio of the distances of the object and the image. If we take the object distance and the image distance as V and U, then it can be given as minus V by U. So this is the linear magnification by giving the object distance and the image distance. So this will be used for the formulas. So we can just write these two formulas together as h2 upon h1 is equals to minus V by U. So it will be used in the problem solving. So here you can see the first problem. What is the question is, find the size, nature and the position of image formed when an object is placed at a distance 50 cm from the concave mirror of focal length 10 cm. So we can say that the focal length is 10 centimeter, then focus may be from the pole is at 10 centimeter. Now since it is a concave mirror, so here we have to see that how the object will give the image. We know that object distance is 15 centimeter because it is say that the object is kept at a 15 centimeter from the concave mirror, and the focal length is 10. But the focal length is always taken negative because the focus is always at the mirror's in front side, that is the bent-in surface of the concave mirror, so it is in the left part. So the left part is always taken as negative, so the value of the f will be negative. And the object is also kept at near the focus, so the value of the object distance will also be negative. So on keeping these values of u as minus 15 and f as minus 10, we will be calculating the value of 1 by v. Here you can see this minus 1 by 15, minus 1 by 10, and on just taking this to the right side, we will be getting plus 1 by 15. On just solving this by taking the LCM of the denominators, we get 1 by 30, which is on reversing, we will get minus 30. So this minus 30, what it is telling that the object's distance was taken as minus 15, that is in front of the mirror. So image is also formed at the in front of the mirror because it is minus 30. So minus is for the real image. So we can say that the nature of the image is real and inverted image is formed by the concave mirror. Similarly, what is the size? For finding the size, we can just take out the magnification formula by taking its v and u, that is minus v by u. Since the value of v and u both are negative, so minus 30 upon minus 15 will be positive 2, but in the formula itself there is a negative, so it will be minus 2. So magnification is minus 2. So by giving the m, we can find out the height. So m is equals to h2 upon h1. So h2 upon h1, we now know that the height of the image, height of the object is 1 centimeter because it is given in the question that the object of size 1 centimeter is kept at 15 centimeter distance from the pole. So here the height of the object is 1 centimeter. We have to find the image height, so it is minus 2. So we can say that the image is minus, so that it is bottom part, that is down of the principal axis. So we can say that it is bottom, so the image will be real. So the image is inverted, so it can be real and the inverted image. Okay, so the second problem here, similar, an object 2 centimeter high placed at the distance 16 centimeter from concave mirror. So distance will be of f, so value of f will be 16, or the object distance will be 16, that is u is equals to 16. So value of u is 16 and produces a real image 3 centimeter high. Here it is given that the real image, so value of u will be taken as negative because the object distance is also kept at a left side, and the image is also real, so it will be taken as negative, and the height of the image is also given and the height of the object is also given. So we can find the magnification. So on taking the magnification h2 upon h1, here the image height is 3 and the image object height is 2. So 3 by 2, it's 1.5, but the minus was given in the formula, so it is minus 1.5. So magnification is minus 1.5. So to find the image and the object distance, we can again use the magnification formula as minus v by u. So putting the values of v and u, we will be getting minus 1.5 is equals to minus v, and for u, since it is a real image, so it is formed in the front of the mirror at the left side, so it is taken as minus 16. So on solving, we got v as minus 24. What does it mean? V is also minus 24, so the image is also formed at the left side, so we can say that the image is the real and the inverted part. So to find out the focal length, we can use a mirror formula, that is 1 by u plus 1 by u, 1 by v plus 1 by u is equals to 1 by f. So putting the values of 1 by v and 1 by u, we can find the value of f. So here the focal length is minus 9.6 centimeter, and what the object distance was, it was 10 centimeter, sorry 16 centimeter. So the image and the object are formed between the focus. So the third problem you can see here is a concave mirror produces 3 times magnified large image. So we can say that magnification is minus 3 and the real image of an object is placed at 10 centimeter. So here the image distance is given as real, that is image is real, so we will be taking the object distance as negative. So the object is placed at 10 centimeter, so it is taken as minus 10, and image distance we don't know because we have to find the value of v. So magnification can be given as minus v by u. So on putting the values of magnification, that is the image is 3 times magnified, so we can write it as 3 as minus 3. Since it is real image, so it will be minus 3. and it is left of the mirror, so it will be taken as -10. So on putting the value of u and m, we can find out the value of v. Now the v is also negative, so we can say that the image is located at the distance 30 centimeter, but in the left side of the mirror, so it is in front of the concave mirror. So we can say that the object formed by the concave mirror object placed at the left side got the image in the left side from the concave mirror, so the image formation will be the real and the inverted image. Okay, so these are the sample problems related to the mirror formula and the image formations by the concave mirror. So we can use this rules for the light rays and the image formation of the concave mirror and the mirror formula. This will be useful for the numericals. So in the next class we will be seeing about the rule of the image formation of the convex mirror as well as the introduction to the lens. So in the 2 classes we will be completing the lens also, and after that we will be going through the numericals used in this chapter. Okay, thank you class. So just revise these topics which we have learned in this class. So if you have any queries, you can just ask me. Thank you.